Today's lecture about finding the charge to mass ratio of electrons. So for finding the charge to mass ratio of electrons, such a device is used. So here if I zoom this part of the device, it will look like this. So inside this part we have the two coils which is labeled by the golden colored. Here these coils are parallel to each other, and inside this coil we have a bulb like shape. This bulb actually consists of the gases, okay, and it inside it we have the electron gun. This is that bulb, and inside this bulb we have this uh, electrodes, okay, and similarly here we have the cathode. We have the cathode and the electron, which is called the electron gun. So here in this portion, due to the external electric current, the resistance will be increased, and due to that resistance the heat will be produced, and due to that heats the electrons will eject from this filament, okay, and that electron is attracted by these electrodes, okay, and the potential provided to this electrode is used to increase the speed of that electron, which is produced due to thermionic emission. So here outside this bulb, we have the magnetic field which is provided by these parallel coil. This electron which is accelerated by this electrode, when subjected to external magnetic field, as we discussed in the previous video, if the electron is moving in the external magnetic field, it will deflect, it will change its path and will follow the circular path. So here is we discussed that if we inject the electron from this side toward this magnetic field, which is from your screen towards you, the direction is this, and if the electron is moving from this side, and if it enter to this magnetic field, the force F will be exert on this and it will change its path. Okay, so here this is the electron, and if it enter to this magnetic field, it will change its path. Okay, the same case is present here, because in the external of this bulb we have the Helmholtz coil. So we have these coils around this bulb, and these coils produce the magnetic field, and inside this bulb we have the electrons in motion. In this case, when this electron, which is produced due to thermionic emission, start motion is accelerated by this electrodes, and the motion, when that moving electron is subjected to external magnetic field, the force F will apply on that, and due to which it will compel on the in the circular path. This circular path of the electron is come from the force exert on the moving charge due to the external magnetic field, which is given by the Lorentz force, which is equal to QV and B. Okay, and this force will exert in such a way that the electrons will follow a circular path. So that circular path, so the force in the circular path is given by centripetal force, okay, which is equal to mv square by r, which is given by the mv square by r. So here this centripetal force is result from this Lorentz force. Therefore we can write here is these forces are same. So therefore the right sides will also be the same. So this is equal to QMV B. here this V and V will be cancelled, and it give us the mv by r, and which is equal to qb. Okay, so here we divide this side by b and similarly this side by b, and it will become m v divided by rb, which is equal to q. So in this next step, we will divide both sides by the m, and which is given by this. So here m v divided by m r b, which is equal to q divided by m. So here this m and m will be cancelled, and it will give us this value. So in this side, this will be cancelled. It will become v divided by r and b, okay, and which is equal to the q divided by m. For finding the charge to mass ratio, we required V, R, and B. So V is actually the speed of this electron. Okay, we will, if we have this speed of electron, and similarly the radius of this circle and the strength of the external magnetic field as provided by the coil, then we will find this charge to mass ratio. So for finding these we require that. So for that, for finding the velocity, okay, so here the kinetic energy of electron is given by half mv square, 1 over 2 mv square, and its potential energy is given by the external, which is given by the q and v. So here we can write as kinetic energy is equal to half mv square is equal to q, okay, and the potential provided to this device. Okay, so from here we will find the v. Okay, so here this v square is equal to 2qv. Okay, so this v square is equal to 2q, and this is the capital V. This is actually the potential, and this V is actually the speed of that electron, and it is divided by the m. So this is v square. So for finding the v here, we will take under root, and it will become v is equal to square root 2q, and this is the potential divided by m. So we have this relation for the speed. So put it here. So if we put that there, then that equation will become this. So this equation, let's say this is equation 1, and equation 1 now implies that instead of this v, we will put this. So here q by m is equal to v, and v is given by this. So we have this v. Okay, we have this v 2q, and we have this potential divided by m. This is actually the v. Okay, and it is divided by r and b. It is divided by r and b. So here taking the square on both sides. So in order to take the square on both sides, this will become q by m. Okay, charge to mass ratio whole square is equal to, so that square and this square root will be cancelled. It will become 2q, and this is the potential. Okay, and this is divided by m. Okay, and similarly we have these. So when the square will be on this r and also on this b, so here it will become r square, okay, and b square. So from here this q by m is cancelled with this one q by m. So here it will become q by m, is equal to 2, and this is the potential, okay, and which is divided by r square and b square, because here this m and q is cancelled with this m and q, and 1 q by m is remaining here. So here we know that in order to find the charge to so from this equation, in order to find the charge to mass ratio, we will know the potential difference, okay, and we have to know about the r, and similarly we have to know about the b. Okay, so for this equation, this v is actually given, so which is given by this device. The v is the potential, okay, which is given by this device, and we have the voltmeter and this device. Okay, this v is known, and this is the constant, we know about this. Now how to find this r? R is actually the radius of the circle. If we provide this potential, and so here if we provide this potential, then due to the external magnetic field, if we provide the potential to these free electrons which are produced due to thermionic emission and accelerated by this voltage, and when it and with it enter to the magnetic field B, it will be deflected. So that deflection in the form of the circle. So here from the center toward this side, we will have the radius, and that radius we can easily determine from this. So we have this ruler, and this is about the center of this circle. Then from this center to this side, we have 11 centimeter. Okay, so we will find the radius in this way. This was about finding the radius. So here it also become known. Okay, now this B has remained. So how to find the magnetic field of this coil? So for that we have this formula. Okay, so we have this formula, that magnetic induction, that B is given by mu naught. Mu naught is actually, we have permeability of the material, and it is constant, which have a constant value. So this 4 and 5 is constant. So for 5 we use 3.14, and similarly 2 and pi is constant. And here this capital R is the radius of that coil. So the radius of this Helmholtz coil. So this coil will have some radius. We will put that radius here. Okay, due to during the purchasing and that instruction manual, we have the value of the radius. So we will write this R from there, and here this N is actually the number of turns present in that coil. So we have this coil, okay, inside this coil we will have some large number of the turns, okay, and we will put that large number of the turn instead of this N, and here I is the current which is provided to that coil in order to produce the magnetic field, and it is also known, okay, divided by this R is known, and similarly R by 2 is also known. So in order to find the magnetic field for that formula, we will use these parameter, and inside these parameter, no parameter has left. Okay, so therefore this B is also determined in this way. So here this also determined. So in order to find the charge to mass ratio of electrons, we will multiply 2 with the voltage which is given by that device, and divided by R square. R square is actually, R is actually the radius of that circle. Okay, and here we have this B. and this B is given by that formula as I shown. So here these all things are known, therefore we'll put that and we'll find the charge to mass ratio of electron.